Hello everyone. So this is going to be a short video for the revision on our chapter 3, multiple integration. But definitely I am unable to cover everything here as chapter 3 is the bulk chapter. Anyway, I only will mention what is the most fundamental thing that you all should remember in this chapter. By applying the same fundamental, you actually can solve different kind of question. Alright, so let's begin with the revision. Basically, in this chapter, we learn how to apply double integration and triple integration. For double integration, we actually have the Cartesian and also the polar coordinate one. For the Cartesian, it's going to be double integration f dy dx. Meanwhile, for the polar coordinate, it's going to be double integration f r dr d theta. While for the triple integration, we have Cartesian, cylindrical coordinate, and spherical coordinate. For the Cartesian, the equation is raised forward is going to be triple integration f dz dy dx. Meanwhile, for the cylindrical coordinate, is going to be triple integration f r dz dr d theta. While for the spherical coordinate, is going to be triple integration f rho square sine phi d rho d phi d theta. Alright, so in this chapter, we actually learn how to apply all the equation here, in particular, to find the volume of a solid. Alright, so let's begin with some example in order to recall you back how actually we go to find the integration limit for the base region and also for the height. Alright, so basically for all the object that you have, remember to always sketch the base region. As after you sketch out the base region, everything will become more clear for you. For example, for the object here, it's very obvious the base is a full circle. Therefore, this will be the base region with the radius equal to 2. And the standard equation for the circle here is going to be x squared plus y squared equal to 4. Now, if I ask you to find the volume of the solid by using double integration, it's going to be double integration height dy dx. To find the integration limit for the dx here, it should be the exact value. So, when you go back to the diagram, the lowest dx here is negative 2, while the higher x is equal to 2. Therefore, the integration limit for dx should be from negative 2 to 2 is the exact value. Meanwhile, the integration limit for the dy here should be in the function of x. Again, it should be in the function of x. So as you can see here, the bottom y is equal to this function, while the top y is equal to this function. Therefore, the equation here for the integration limit will be equal to this one to this one. Alright, so for the second object, again, we also have a very obvious base. So what I will do is, I will sketch out the base region first. Okay? Alright, so from the base region, I also can find what is the integration limit for my dy dx. So again, for the dx here, it should be the exact value, and this exact value run from 0 to 2. Therefore, the integration limit is from 0 to 2. Meanwhile, the integration limit for the dy here should be in the function of x. Okay, so the bottom graph here is going to be this function x, while the higher function here is going to be this function negative x plus 4. Therefore, the integration limit here is from x to negative x plus 4. Alright, so after you find the integration limit for the base region, we actually need to find what is the value to put into here, the height. So when we see that the three-dimensional solid here, you can see this will be the height, this will be the height, and this will be the height. And you can see that the height is always the top function minus the bottom function. The top function minus the bottom function. The top function minus the bottom function. Therefore, the height is going to be the top function minus the bottom function, whereby the bottom function here is equal to 0. Same goes to the second example. In which the height is always equal to the top function minus the bottom function, top function minus the bottom function, and the top function minus the bottom function. Therefore, the height is always equal to phi minus 0 because the top function is always equal to phi, while the bottom function is always equal to 0. However, you need to take care when you have these kinds of object, in which now the height is from here to here, from here to here, and from here to here. Therefore, the height is always the top function minus the bottom function. So this will be the top function minus the bottom function, whereby the top function is you get by rearrange this equation into z equal to something something. Alright, so this is how we find the integration limit and also how we find the height when we do for double integration. If let's say you want to do it into a triple integration, actually it's very easy. The dy dx, you use where the integration limit that you get for the dy dx you do for double integration. While for the integration limit for the dz here is just to change the height become the integration limit. So integrate from the bottom to the top. Okay, so it's same thing happen to these two questions as well. So with this, I will end my revision for this chapter. If you have any topic that you are not sure regarding chapter 3, let me know and I will try to make a revision on it. Thank you.